Welcome back, everyone. How is everyone doing? Perfect. What do you think about the content so far? I hope we'll continue with the same way for the rest of the day. And thank you so much for coming. My name is Anchal Gupta, and I lead information security team at Facebook. So I had this pleasure and honor to put this particular session together. And I had so much fun doing it, but at the same time, it was very challenging. Why? Because we had only 5 spots, and there were so many great submissions for this session. That shows that there are so many passionate people out there who care about security, privacy, and online safety. So considering that, putting or selecting just 5 leading voices was really hard. I had to disappoint quite a few people. Hopefully, they definitely get a chance to speak at another stage. So I'm going to do slightly different, non-traditional introduction for my speakers, because they are sitting some in the front row, because they are so well known in this space that you already know their achievements. I don't want to go over those. I'll talk about the stuff that you don't know about. So you may want to pay attention to their intros, because then later on maybe you can blackmail them with some of this. We'll see. So our first speaker is Kate McKinley. She is from Facebook, and she is right now working on securing our Oculus platform. So all the augmented reality, virtual reality stuff that you see. So after her talk, you can definitely bug her about this. The fun fact about her is she is a photographer and filmmaker, and she is currently working on her first feature-length documentary about Japan Night at South by Southwest. So while working on some of the really critical stuff, you will notice that these ladies are finding time to do some other exciting things too. So let's welcome Kate, and he's going to talk about memory safety. Kate.
Do you have the clicker? Thank you. Thanks for the introduction, Anchal. I'm Kate McKinley. I'm security partner for Oculus at Facebook. And today I'm here to talk to you about what is the longest running crisis in technology, computer security today. And that is that we're working with languages that are inherently unsafe. And first, I want to talk about a little bit about what memory safety is. There's a definition on the screen, but it's the property of a language whereby the program is not allowed to access or cannot access memory that it hasn't allocated or been given explicit permission by the operating system. And unsafe languages leave programs open to a lot of different attacks. So some really common ones are access to uninitialized or previously freed memory, buffer overflows. We also see race conditions, memory leaks, and type confusion. These are just the names of some of the attacks. But what they do is they allow an attacker to essentially take control of your program and take control of your computer. Let's see. So we have a number of mitigations for these kind of attacks. For example, we make a stack on our programs non-executable. We randomize the layout of our libraries. We make sure that pages in memory are either executable or writable. Additionally, we have more advanced technologies such as canaries, where we put random values into the program at runtime to make sure, and the operating system can ensure that that is not modified during runtime. And sandboxing, whereby we separate our processes into different privileges. Additionally, we've developed a lot of tools over the years for static analysis, address sanitization, and recently Firefox has started integrating formal verification into its libraries. So NSS specifically uses formally verified cryptographic algorithms, which allows you to make certain proof statements about that program and about its safety. But all of these are bypassable. So we found that we can, if we can't make our attacks on the stack, we can make our attacks on the heap. We can return into libraries that are known to be safe and find code there that does what we want it to do. We can actually find the location of a lot of these libraries in memory and then use that as the information to make exploits work. And even last month, one of Microsoft's most recent protections was shown to be bypassed by some researchers at Black Hat Asia. And if we look at the number of vulnerabilities here, in roughly the last year, about 80% of Chrome and Firefox vulnerabilities that were marked as critical were due to memory safety issues. There's some other numbers up there for Mac OS. OSS Fuzz is a project by Google to help find vulnerabilities in open source libraries. And they found over 1,400 issues. And most of that is just, we could find more if more projects were on this, on OSS Fuzz. And Project Zero's vulnerabilities, 70 out of 86 critical vulnerabilities that they've reported and are public today are due to memory safety. So this is a really big crisis. I think I've got my slides out of order. I talked about mitigations. So what we need to do is we need to bypass the C programming language, right? We need to make sure that we are working with languages that are safe by design. And to do that, we have to understand what our developers' use cases are. We can't just go to them and say, hey, use this cool new language. We have to understand why they're choosing this tool and how we can help them use it properly. Whether they want to use Go, Rust, Swift, whatever they want to use, but we should be encouraging them to use these languages. One of the issues that we have with this, of course, is tooling. A lot of times, new languages don't come with the best tooling. And so that is a thing that we can work on. We can help them discover new tooling. Since Rust is now used heavily by Firefox, that tooling has increased substantially. We also need to make sure that our languages can interface with the existing things that we're using. We're not going to replace 100% of all C code ever written in a short period of time. This is a long-term project, and we have to be geared for the long term. So we need to be able to interface with the existing libraries that are in use. Additionally, we have to be sensitive to performance issues. Sometimes adding a small amount of memory can substantially increase the cost to a company of delivering your products or services. And finally, we can start by doing similar to Firefox and replacing the most dangerous components first. So for example, Firefox replaces libstagefright, which has a number of vulnerabilities, not just a lot of memory vulnerabilities in how it processes SMS messages and things like that. And so replacing these most dangerous components is probably the best way to start. So we have to be careful about this unstable foundations that we see. So a lot of times these are written in C. So if you're trying to use a language like Python or JavaScript, you may still be running on an unstable base. Example is last year, Microsoft Edge had a series of issues with out-of-memory vulnerabilities, which were used to gain access to other regions of memory. And these were vulnerabilities in the underlying C code that ran the JavaScript interpreter. So these are our interfaces, are these libraries. And we also have to understand that this is not going to protect us against logic bugs. But I think if you look at the number of issues that are just due to memory safety, we can just get rid of a lot of them right away. So this is my advocacy. I think you should all be using Rust. But again, there are a lot of other good languages out there. And these languages have good online communities. They have ways to learn. There are online compilers. Take a moment, learn about these languages, contribute to development, make the world a better place. Thank you.
Thank you, Kate. That was excellent. So our next speaker is Leigh Honeywell, and she is at present a technology fellow at ACLU, but that's going to change very soon. In 4 weeks, she is starting her own security company. So if you're looking for jobs at startup, you may want to talk to her. Fun fact about her, and I want to make sure I get the number correct here. She was once 804th best downhill ski racer in the world. So come on over.
Thank you. Oh, is this quicker? Great. Thank you for the wonderful introduction there. Yes, very briefly, 804th. Only in the downhill discipline, not slalom, not giant slalom. Just downhill is like 1,200. Anyway, so yeah, halfway between heaven and hell, how do you secure grassroots groups? So I apologize for like double fisting it here with my phone. We don't have the little presenter mic or presenter screen. So my name's Leigh Honeywell. I've made an entire career out of putting out fires involving computers. I'm now at the ACLU, where I'm a technology fellow. Instead of putting out fires involving computers, I explain computers to lawyers so that we can sue the government. So this is the Golden Gate Bridge. In 1933, the Golden Gate Bridge made history by making an unusual decision for the time. They spent $130,000 of 1933 money, which is like a couple $1 million of today money, putting a net across the bridge. It was the first large American infrastructure project and one of the first construction job sites in the world where they put a lot of thought into having a safe job site. So they had this net. They got the riveters who were welding red hot rivets into lead paint. Lead paint was they were totally okay, like using the lead paint. They were just like, maybe we shouldn't breathe it in. So they got people to use respirators, and they required hard hats. It was the first job site in American history that required hard hats. And measures like this saved so many lives. It was a very, very safe job site. Only about 11 people died in the multi-year project of the Golden Gate Bridge. These are 6 of the 19 members of the Halfway to Hell Club. Falling off the bridge while it was under construction was called going to hell, and these were 6 of the 19 men who, in the multi-year construction of the bridge, were saved by the net. So the reason I bring this up is to get you thinking about safety and what safety is in software, what it means to be designing software that is safe for its users. In December of 2016, about 3,000 people, maybe a few people in this room, signed a pledge called the NeverAgain.Tech Pledge, pledging to refuse to participate in building the engines of deportation and the engines of genocide, refusing to build databases of people by their religion, thinking about data minimization in software, and where we should be just like deleting data, not having data. There was a great tweet sometime around fall 2016 that was like, the last line of defense for user safety is a bunch of SREs with sledgehammers. But it doesn't always need to come to that, right? We can get ahead of the game. And the pledge was 2,800 technologists saying, we are going to get ahead of the game. We're going to think about where we should be deleting data, refusing to collect data in the first place, and designing secure systems that minimize our need to have insight into people's data. So some of the things that I learned from this were about the actual safety piece, but I learned a bunch of meta things in organizing this pledge about how to work together with people securely in a loose-knit fashion across organizations. Because when we're talking about designing software, we often think about designing software for companies that are like somewhat well-defined collections of people that have sort of boundaries, and the firewall. People have been saying the firewall's dead since before I was even in this field, which was like 10 years ago. But there's still the idea of like a perimeter. Your organization has a list of employees, and even if you're interacting with other organizations, there's sort of like those are known interactions. You've got a contract with the other company that you're sharing data with. But we're starting to see a lot of work styles like BYOD and Beyond Corp and all of this stuff where people are like, well, maybe it's actually nice to work in a lighter weight way. And then, of course, there's people who are fighting the good fight to protect individual users, whether it's the Bird site, Facebook, all of these other things, thinking about ways to do user education, authentication based on people's like social connections and relations, two-factor authentication, getting people to do that kind of thing. And also thinking about like how can we just take ourselves out of the equation, whether it's end-to-end encryption or again that data minimization piece. And that's why I'm really glad to see people doing things like implementing, even if it's just a little secret conversation mode that you have to drop into. It's really great for like sending my sister my dad's passwords when he forgets them, which is frequent. But yeah, a lot of organization is fundamentally a loose-knit collaboration of people using tools that have been designed for a soccer team to do activism and more serious things, but they're using tools that are not designed for that. So as you're building new systems, as you're building new products, the thing that I ask people to think about is what is that squishy middle piece that is not an organization, but not just an individual? And how do we enable and build secure systems that protect those users? And some of it is getting the actual users to shift to like a security culture, right, of minimization, of least privilege, of all of these sort of buzzwords that we know as security professionals. How do we get the people using our software, using our products, to be thinking about that? And one of the things that also got me thinking about is that there's, with all of these like civil society groups that are organizing, whether it's the current administration or other countries around the world that have governments that are even more hostile, we as security professionals have a responsibility to reach out to those groups and not just be like, use Signal, use Tor, but really work to understand, I mean, that's important, but work to understand what those groups' needs are, how we can help as security experts, share our expertise with them. And to also be remembering that there's two big buckets of adversaries, those operating inside the law and those that don't care about the law. And to think both as we're protecting organizations, individuals, and the squishy middle in between of collaborating individuals, that those are both of our like we have to be thinking about both of those threat models. And one of the reasons that I had all of these realizations in working on the NeverAgain.tech pledge and in my more recent work at the ACLU was getting to work with a lot of people who were not like myself. And I think that sort of lines up with what we're doing today here to see what are the people working on security issues that don't look like ourselves, working to reach out to those people, reach across, whether it's the aisle, the cubicle, or the conference room, and say, like, hey, what do you think about this? What has your experience been that has been different, and how can I use that to be a better security practitioner? So I had a long rant in this last slide about what I'm doing at the ACLU, but I'm not going to be doing it for much longer. So if you go to my Twitter, you can find the job posting if you're interested in explaining computers to lawyers so that they can sue the government. And my slides will all be up here. So thank you very much.
Thanks, Leigh. That was awesome. So I really like the way she compared the maturity of our software security with those nets and the hard hats. It seems like we are still at that stage that we are putting the safety nets around, we are putting the hard hats, as opposed to getting somewhere where we can call it really mature organization from security. So our next speaker is Kelly Leung. OK, Kelly's out there. So she's a security engineer at Spotify. And in addition, she is a professor of application security at New York Tandon School of Engineering. And when she is not doing these two things, she is a semi-professional small plane pilot. So we can ask her later on how she does so many things. And today she is going to talk about encryption and how to scale it. So here we have Kelly.
Awesome. Everyone can hear me all right, I presume. First of all, thank you so much, RSA and everyone, for having me. It truly is an honor to be one of the few selects. I see they're going to start talking crap about me up on that screen, so I'll try to not look that way. This is not about something that I'm currently working on at Spotify. This is something that I worked on maybe in a life or two ago. But my life was when I worked for Tumblr, my life was all about certificates. I could not spend a single day without thinking about certificates. And I think we've been thinking about encryption, HTTP, TLS, whatever we're calling it right now. We've been thinking about this for ages and ages, right? And so this is my life in the cert trade. This is a Boy Sets Fire reference. If you recognize this, I'll buy you a drink. Probably not. But who am I and why would you care about anything I have to say? I've been around the block, started out in the government, worked for finance for a while. Now Tumblr, Spotify, kind of getting into that whole waking up at 10 in the morning, getting wear jeans lifestyle. So here's what the problem statement was at Tumblr. And I'm probably actually going to go under time because I talk really fast, unless I go on a rant. We wanted to get as much of our blog network over HTTPS as possible. We had, the Tumblr dashboard, anything that you logged into, anything that was dealing with sensitive information, that had been over SSL, TLS for a very long time. And there were two problems with getting the blog network over HTTPS. One is that we had sort of a mixed content issue. We had a lot of users who didn't really understand why they should have their blogs encrypted. And then there was also the problem that a lot of people had custom domains, right? The people who actually wanted their blogs encrypted they really wanted it for money purposes, for SEO purposes, basically to make their overall organization look cool and secure. The people who actually might have really needed it were people who probably didn't realize that they needed it. You are a blog that serves content that is maybe gay, lesbian, LGBT+, and you are serving to a lot of people in Russia or a lot of people in another country where the marginalized people could be punished or penalized for accessing that sort of information. So we wanted to figure out how to get those blogs over HTTPS while making the experience, one, user-friendly. We didn't have to want to make our users go out, generate a CSR, send us a certificate, understand what public-private key infrastructure was. And we wanted to make it as inexpensive as possible. Remember, we're a startup. We really got to not pay our content distribution network to do it for us. No offense, Cloudflare. We love you. So then this wonderful thing came along, and it seemed like a miracle. It was really great for everyone. Let's encrypt. Love it. Love it, love it, love it. But the impression of Let's Encrypt for a lot of people, they're like, oh, OK, I click a button, I install an app, all of a sudden I have a beautiful certificate that I can pop onto my web server. Not so easy when you have thousands and thousands of web servers in your infrastructure, right? Not so easy when you have a lot of different domains owned by a lot of different people, a lot of different individuals. It's not just Tumblr domains. It's not just company.whatever-makes-chocolate.com domain. It's individuals. Kelly wants a domain. LimpBiscuitRules.com wants a domain. Very important, LimpBiscuitRules.com. So there's lots of cool tools and clients that can interact with Let's Encrypt, that can follow that process of talking to the Let's Encrypt servers, generating that wonderful certificate information, and getting it so that we could put it on our servers. But is there any one that would work in our infrastructure? And now there probably is. This is something that was in the works for three plus years. When Let's Encrypt was very, very young, there wasn't a lot out there. Now there's a ton of stuff. So really, we couldn't find anything that worked with our infrastructure. PHP, it's beautiful. But how does Let's Encrypt work? Just as a gentle primer, want to also just kind of get people to understand the problem statement that you can't really just tell a user, oh, you want an encrypted website? Use Let's Encrypt. What's wrong with you? It's so simple. There's a lot of different steps that you have to do. One, you have to let Let's Encrypt know that you want a certificate for a domain. I'm not going to read all these slides. You can get them later. Two, Let's Encrypt is going to say, you want a certificate for that domain? Prove it. Here's a challenge. Here's a thing that you have to sign all your stuff with. Host that challenge. And if you can actually host that on that domain, we like you. We'll let you have a certificate. Once you prove that you own that domain, then you can then talk to Let's Encrypt. Let's Encrypt will say, you're good, you're copacetic, give us a CSR. That's when you actually do get your certificate information. But that's only half of the problem. We understand how the system works. That doesn't seem so hard. But what does the actual communication format look like? Does anyone here like reading RFCs? I fucking love it. Sorry. So what does that communication look like? Is there a header? Is it formatted in XML? Is it a JSON payload? We had to really figure out, look at a lot of previously written code, look at the RFC, or look at all this stuff, and figure out how this works. So not just as simple as press the button, get a certificate. Again, keep this in mind. The solution that, and I'm not saying this to diss Let's Encrypt. Let's Encrypt saves our lives. Let's Encrypt made us able to provide this service for our customers in a way that they didn't have to understand how to do anything. All they had to do was flip a little switch, and they didn't have to pay any money for it. Accessible and just so much easier than what we had before. But then, now how do you get those certs? And I kind of underestimated here. I said, oh, there's a lot of little databases, and oh, there's a lot of servers. Thousands of servers, right? Distributed, distributed computing, right? Lots of databases in the back with private sensitive information, lots of web servers in the front that need to have our certificate stuff installed. So we made a Scala service. That's it. Keep all of our private secret stuff back here, have something that can cache those requests, and if we do have a request coming in for a domain where we haven't loaded that certificate information, we reach out, grab it, and pull it in. Very sort of dynamic. Do you have a is this requesting a site for a certificate? Do we have a certificate? Give it up. Looking at my notes to make sure I didn't miss anything. Nope. I also wanted to get in, this is something that I glossed over a little bit, is in terms of our design decisions. We really wanted certificate usage to be opt-in, one, because it really was all about that user experience. You flip on HTTPS, TLS, whatever, for all of your sites, it's going to break a lot of stuff. You may have hard-coded links that all of a sudden don't work. You may have JavaScript that isn't going to load because of mixed content problems. Same thing with cascading style sheets. All of a sudden, your beautiful page that you paid a designer thousands and thousands of dollars looks like something from 1998. Not cool. Also, we wanted to keep under the rate limit, right? We also don't want to break the experience where, we're pounding Let's Encrypt, this wonderful service that we want everyone to have access to, just by constantly hammering it for every single domain that has an HTTPS request going to it. I've talked to some other people, and I will not name names because I am not a snitch. There are some other companies that sort of did a different approach to this. They actually did, and they didn't do it all at once, but they actually said, here are all of the websites that we host that have custom domain names. We're just going to go out to Let's Encrypt and generate a certificate for all of them. We didn't want to do that. We did not want to have that on us. We did not want somebody to be like, who the hell are you, and why did you generate some private certificate information for us? I didn't ask you to do this. Now somebody can steal it and pretend to be me. We really wanted the concept of consent and deliberation in terms of, I am making a conscious decision to opt into having my site encrypted, and I may not know why I want it, but I'm telling you that I want it. Sort of like me and candy. All right, 43 seconds left. Thank you very much. If you have any questions, just grab me after. Again, thank you so much for having me and listening to me being hyper. Bye.
Thank you, Kelly. That was amazing. I think she has set a really good example as to how we as security experts should think about providing solutions. Because we at times think about, oh, this is a solution, and we don't really ground it in reality. We don't think about how that's going to work for our users, for our engineers. So next up, we have Jen Taylor from Cloudflare. She is head of product and design. And when she is not doing product security advice, she is doing whitewater rafting guidance. So she was at one point a professional teacher/coach for it. So you can still connect with her to get some tips on that. And today, she is going to talk about DDoS, believe it or not. So she'll make MiraiBot look like a piece of cake. Correct? Perfect.
Perfect. Thank you. Hi, I'm Jen Taylor. I'm head of product and design here at Cloudflare. And at Cloudflare, we have over 8 million sites and applications on our network, which means as a result of serving individuals, large enterprises all over the globe, we see a broad variety of traffic. The good news is a lot of that traffic is good. The bad news is a lot of that traffic isn't. But what we do here at Cloudflare is inspect our traffic to identify threats and then focus on ways that we can understand them in the industry and help mitigate them. So specifically, when we look at DDoS, I want to orient people as to sort of what the world looks like to an attacker. There are kind of two ways they're going to get you, right? The first is kind of kicking it old school, which is kicking a lot of traffic over your network. So basically, flooding your network with huge volumes of traffic, basically to clog up your pipes. And that's kind of, when you read headlines about big DDoS attacks, these are the things that typically hit the headlines because they're sexy, right? It was this big, and it's very compelling. What we've actually seen more of more recently are more targeted attacks where attackers identify a specific choke point or vulnerability with a site and then just hammer that site with a huge volume of requests. So whereas large bits through the pipe will slow down the whole network, request-based attacks have a tendency to just slow down a single site or application. And of course, there are those enterprising attackers that manage to do it. When that happens, frankly, everything hurts. So looking at the world of those large volumetric attacks, you'll notice over the course of the last of the 10, 15 years, these attacks have grown exponentially in their size. And if you think about sort of why is that? Well, you know, if you think about, like, what did our networks look like in 2007? Like, to clog up the pipes of a network in 2000, they were smaller. We didn't have as much capacity. Part of the reason why these attacks keep having to get bigger is that our networks and our infrastructure are just getting bigger and bigger on a regular basis. Now, looking at these attacks in the life in a year here at Cloudflare, looking at these large volumetric attacks, you'll notice that they're fairly consistent. We have some that really spike, but for the most part, they're fairly limited in the frequency. And one of the things we did last September is we announced unmetered mitigation, which means we no longer kick people off our network for bad traffic. And as a result, you kind of notice they really trail off in the last quarter of the year. Mostly it's because, like, attackers are like, oh, man, that's no fun. I'm going to go move on to something else. Now, that doesn't mean that the volumetric attack is dead. In fact, what we actually see with attackers is that they're enterprising individuals. And what they do is they kind of change their pattern. And so you'll notice here, again, another year in the life of Cloudflare, you know, we continue to see SYN flood attacks on a fairly regular basis. You will notice, though, that after we announced unmetered mitigation, the attacks just become more spaced out. Again, attackers are sort of like, you know, it seems like they kind of got that nailed. I'm going to move on to something else. And that's kind of where we've seen the industry moving. Now, I talked about kind of life in the year. If I just look at what my last week has looked like, this is sort of what we've seen on our network. And I actually had to have our designer update the slide this morning because we had a gnarly SYN flood attack this weekend. But what is actually interesting here is that these aren't necessarily huge, like, network sweeping volumetric attacks. What we're noticing is that a lot of attackers are going back to old tried and true methods using UDP protocols and reflection and amplification attacks. So here at Cloudflare, we basically have seen an attack on our network every 40 minutes for the last 6 months. And if you were to look at the inventory of what they are, they're some of your favorite UDP protocols. And people are like, what's going on? Like, why is that happening? Well, like, top of the list is NTP, right? That's the time protocol. And if you think about what's happening in the industry around applications and devices, I probably have like 3 devices on my body right now that are leveraging NTP to stay in sync via time. And if you don't lock down that server, you're creating an attack vector. Similarly, SSDP, the plug-and-play protocol, has also become an interesting attack vector. And this is one I actually want to spend some time on. So it's the plug-and-play protocol. You leverage it over port 1900. And the thing that's really interesting about these attacks is that they don't need to be long, and they don't need to be big. But because of the nature of the protocol, it's a chatty protocol, so you can actually, through reflection and amplification, drum up quite a bit of targeted threat attack traffic. This is how it works. An enterprising attacker spins up, probably on a cloud instance, some capacity, and spoofs the victim. They then put out an SSDP request, probably to something like a broadband router that doesn't have port 1900 locked down, floods the broadband routers, and SSDP is a chatty protocol. SSDP gets gets the request, and they're like, oh, hey, how are you doing? Yeah, I'm running an iPad and a DVD, and the packet size that comes back to the victim is typically 22x the volume that they generated. So again, small volume, old school replication, and pushing it back to the victim directly through that. Now, I talked a lot here about what's happening in that y-axis and sort of the shifts that we're seeing in those volumetric attacks. But I wanted to take a moment to see what we've seen starting to happen at layer 7, those request-based attacks that are happening at the application layer. And if you'll notice here again, life in a year of Cloudflare, if you look what we're seeing in terms of layer 7 attacks, it's fairly consistent. It's actually growing in some cases. And you'll notice our intention around unmetered mitigation really didn't do much to deter layer 7 attacks. If anything, you could argue that you see actually some growth. So what does a layer 7 attack look like? So this is a small IoT-based attack that we saw earlier this year. And unlike the preceding attacks that I talked about, they only needed about 2 gigabits of traffic to generate this attack. Not a lot. But what you'll notice is they generated 2 million requests per second. And if you turn around and you point that at a large enterprise, you can bring a site or an application down fairly quickly in a fairly targeted fashion. 2 other things that I find very interesting about this attack is you'll notice it only took about 50,000 unique IPs to generate that volume of traffic. So again, you can do a lot of damage with a small surface area. And if you think about the millions and millions of IoT devices out there, I get a little nervous. The other thing you'll notice is, again, it's fairly small. It's short. And what I'm actually showing you here is a chart of the HTTP traffic by data center. The other thing that we've noticed with these attacks is they tend to be fairly regional, because they tend to target a specific device. What you're seeing here is actually a spike in traffic in this attack from our Hong Kong data center, which means that the device used to perpetrate this attack was probably an IoT device in and around the China market. So in closing, what do you do as an individual? I think you continue to do what you've done already, which is put your service behind a DDoS mitigation solution. You leverage and employ HTTP rate limiting so you can throttle the traffic as you see it. And you continue to buy yourself a little extra capacity above and beyond what you typically would need so you have flexibility if those fluctuations in traffic happen. But most importantly, as we saw with the reflection and amplification attacks and with the IoT attacks, lock it down. If you're not using it, lock it down. Reduce your exposure, reduce your surface area. You basically want to minimize the surface area that you present to an attacker to help perpetrate an attack. Thank you very much.
Thank you, Jen. That was great advice. And now we are on to our last speaker. That's Snyder. She is CSO at Fastly. And I was asking her what is one of the fun facts about you, and this is what she told me. Before starting in tech, she was a seamstress at a costume store. So that's the diversity our speakers bring. They have a lot of different things that they do outside of securing our world. So let's welcome Windo.
Actually have this. Yeah, thanks. So apparently I'm the only speaker who was expecting a podium. So just for me, they found one, which I so appreciate. So I'm sure someone can identify my password by that. So I'm going to have to change that, eventually. So yeah, I used to build costumes in a costume shop, actually. It was a theater. So not a costume store. You couldn't come in and buy them. So actually, I can build really froofy, like poofy, period costumes, but not very well. It actually resulted in 2 different trips to the emergency room. I managed to like sew through my finger. I managed to like take a steamer and like, oh my gosh. So it was great that I eventually moved over into tech because that was not a career I was going to last very long in. So I'm going to talk to you today about how to do application security with a small team, a small budget, or perhaps neither, nothing at all. And just to tell you a little bit about myself, my name is Snyder, and I have worked on security teams at large organizations and small organizations, at Apple and Microsoft, at Mozilla, and I'm currently the CSO at Fastly. And I feel like in this kind of space, you can go ahead, comfortably date yourself, and like not have to worry about, what that means. I started as a software engineer in 1995, and working on primarily security-sensitive systems. This is before we even had an application security industry. We didn't have books. We didn't have conferences. We had hardly anything. We had some folks who'd been working in this space who had come up with some ideas. We had crypto. We had books about crypto. Yeah, that was pretty much it. Application security was essentially just crypto. So things have really changed, but some things really haven't. And one of the things that I see everywhere I go is an underinvestment in application security. And part of that is sometimes it's a recognition, maybe late, that you need this kind of work, that you need this organization in your company. And sometimes it's actually just a difficult time trying to build this organization. So sometimes it's about, like, for a small development or a startup, for a small development environment or a startup, it's easy to trade off long-term strategic choices of all sorts, not just security, for getting features shipped, because it's about delivering and getting to market and capturing the opportunity, and a lot of things, not just security, maybe reliability or localization or you name it, accessibility, don't get the attention that they need until later in the process. And security is, of course, on that list. And for more mature organizations, sometimes they think that maybe their code's not likely to be targeted, that attackers will go after different weaknesses, or maybe their specific area is low risk. So they decide not to make an investment into security, application security specifically, until they start feeling pain. And sometimes that's a compromise, and sometimes it's a competitor with similar technology that's compromised, and then they realize, oh, that could have been us, and then they try and hurry and spin something up. And now you find yourself, if you're this lucky person working on application security in one of these environments, which is every environment, you find yourself thinking, you've got to back security into this situation. You've got a pile of legacy code. Maybe you've identified lots of vulnerabilities, and you've got this massive backlog. Or maybe you haven't found any at all because no one on your team knows how to go looking for them. And you might find yourself attempting to address a huge amount of application security work alone or with a small team. And you might have the headcount to hire folks. But as a lot of you know, this is a really specialized space. To really be effective as an application security engineer, you probably were a developer for some number of years. You started working on security, and that's another several years. And to begin to be effective in the application security space, you're probably already in your career many years before you're going to be really effective in that space. So of course it's hard to hire those folks, and they're incredibly expensive. So it's hard to build those teams. And even if you have the headcount, being able to grow as fast as the application security work piles up, especially as you start to recognize just how deep the rabbit hole goes, it's hard to keep up. So no matter where you're starting from, there are lots of things you can do to dramatically reduce the vulnerability of your code base that you can do with a really small team or with no team at all. The first is to accept that you can't be perfect, which I think most folks in this room recognize, and it's mostly our jobs in the organization to convince everybody else that that's the case. Can't be perfect, and it's all about just reducing our risk. So we make it harder and more expensive for the attacker to go after whatever it is that's valuable in your environment. So we identify assets. Is the app collecting personal information? Do you perform financial transactions? Is your system sending communications? Is code installed on a system or a device that's valuable? That's every device. Is it running on a site with any users at all? An attacker might want to go after the data you store or are transmitting across the network, or even just capture, or even just use your app to compromise the user's device, like a phone, and use that as a stepping stone, an entry point into the system, because the app is probably getting less security investigation than every other entry point into the system. So that is a reason that no matter what your app is doing, that you need to consider this for your environment. Vulnerabilities in the web app could be used to compromise the servers to allow an attacker to host exploit kits that take advantage of security issues in browsers, or to compromise data on the user's machine, or even to mine Bitcoin. Like, the opportunities are endless for the attackers. So they are willing to be opportunistic. So yes, your little game app has value to an attacker. Your little web app has value. Attackers are opportunistic and will make use of all sorts of problems that you might consider beneath their notice. Your lower risk SaaS app might compromise the data of a customer who's actually the real target, and all of your other customers are along for the ride. Defense in depth requires compromising multiple aspects before getting to assets. And so they might be willing to look at, let's say, the content management service that considers themselves low risk because they're just hosting a copy of it, and the one thing that they're doing is pushing it to wherever. So we got that thing locked down, and we don't have to worry about everything else. Absolutely not. This entire space is your problem too. So anyways, we first do the things that we all know we need to do, but for some reason we find it incredibly difficult to get done. So that's building security through all aspects of the development process, whether that's the SDLC or something modeled specifically for your space. It can be very lightweight, but it needs to be a consideration at every aspect. So you work to improve code quality and architecture because you want to reduce the number of vulnerabilities. Move to a higher level language, as one of our earlier speakers brought up. Fantastic. That gets rid of a lot of memory corruption issues. And all these things make it expensive to exploit vulnerabilities. So the vulnerabilities are still there, but it's just harder to make use of them. Leverage the security mechanisms from the platform. Don't roll your own. There's no reason to build it yourself. If it exists in your platform, take advantage of it. It's fine. Oh, we need to build our own allocator because it's more performant if we do. No, you don't need to do that. Every developer wants to be a kernel developer for some reason, but no, don't. You don't need to write your own allocator. You're not going to implement all the security mechanisms that are in place to avoid all the incredibly numerous memory corruption issues that we've seen over the years. So just don't. Use the memory allocator from your platform. There are encryption libraries. Definitely don't roll your own there. Leverage a library for that. Memory management, security training. Yeah, it's for everybody. No matter how big your organization is, yes, you do need to do security training. And that's because you've got this fantastic opportunity with peer review. You want to patch quickly, of course, your whole infrastructure, whether that's the workstation for your devs, your workstation for HR, for your servers, you name it. You want to patch quickly to reduce the window of opportunity for attackers to take advantage of vulnerabilities in all of the technologies that you depend on. And of course they have vulnerabilities. And the 30-day or 60-day or 90-day window that you've got that you've agreed upon to get that patch rolled out, it's a huge window for the attacker because they're being opportunistic about it. They're like, oh, there's a vulnerability out there, and they spray the internet looking for it. So even though your site might not be on their radar, as soon as they identify that your site has this vulnerability, now you are. So you don't even have to be. They don't have to be looking for you. They can just take advantage of the fact that you're around. Reduce the attack surface area. This is something you don't even need security folks to do. They can, you explain a concept to them, and they can go about identifying ways to do input processing, for example, in one place. So instead of having input validation everywhere, you've got it in a single point of place. Isolating components. They can identify core functionality themselves and isolate it and say, oh, this functionality is over here. It should happen on a separate service. These two components should speak to each other through a narrow channel. So we only have a narrow set of opportunities for an attacker to take advantage of a vulnerability that might be anywhere in the system because we only have a handful of APIs that are even available. So if there's a vulnerability, it has to be one of these APIs in order to get from this system to that system, whatever the system might be. This might be a service. This might be an actual machine. You name it. The engineers themselves can identify how to isolate these components, and you leverage the benefit of a pretty robust security architecture through isolation. And importantly, you need to reduce the data that you store. I think this is, I'm really excited, one of our other speakers brought this up earlier today, that this has become something that the industry has been thinking about more seriously. But once upon a time, it was actually quite shocking to say something like reduce the data that you store. Because if you store it, you have to protect it. It's definitely interesting and valuable to somebody. And you're probably not as good at protecting it as you would hope to be. So if you don't need it, don't protect it. We're not later going to come around and use machine learning on it to pull out something. And no, it's not going to happen. AI might eventually produce something interesting for your organization on top of this data, but you can start collecting it at the point in time when you have a business need or a business justification for storing that data. If you don't need it, don't use it. The same reason you shred documents before you recycle them. You don't carry all your money with you at the same time. I take my laptop out of my car before I walk away from it. And part of that is because I live in San Francisco, and part of that is because it's just such an obvious security mechanism. Somebody breaks the window, I'm bummed, of course, because I have a broken window, but I still have a laptop. So, you know, these are things that we, for the most part, know how to do, but it doesn't get deployed at the same level that we would hope to see it deployed in industry. So I think we all have a lot of things, all of our organizations have a lot of things that they want to get done, but it's incredibly difficult to justify doing these things. So these are things engineers can go around doing without you. It leaves your time for other things that they can't do without you. So you can leverage tools if you can. OK, objection. Oh, they produce so many red flags that we can't wade through all of the output and make something useful out of it. Yeah, I know. I feel your pain. But you can outsource this out to the engineers and have the engineers evaluate the red flags in their components. Because earlier, you got them security training, so they know how to identify vulnerabilities in their environment. They do peer review to evaluate check-ins before they end up being deployed into who knows where. And all of this reduces the burden on the application security team, which probably only has a handful of people if you're lucky, and allows you to leverage the resources in the rest of the organization to amplify the impact that your application security team has. So thank you very much. Good luck. It's a very difficult job.
Thank you, Window. And now may I request all the speakers to come on stage. That's okay. Do you, let's switch. Yeah, then I'll be able to see all the speakers in one go. Yeah. Okay, perfect. So you guys talked about a lot of diverse things there, like starting from encryption to securing your network to memory safety to activist safety. And Window talked about like securing everything. So looking at that diversity, I was thinking, when I was talking to you before we came together and spoke at this event, you all have very different backgrounds. Some of you started as product managers, some of you started as developers, and some of you started directly in security. So I want to hear about your experiences when you started in different careers and you transitioned over to security, or maybe you just started in security and what are your experiences? Like, do you feel specific challenges? Do you feel like, I wish I had not started at this particular stage versus I should have started as a dev? I just want to hear from you. And we can go in any order. So whoever wants to go.
Instantaneously looks at me.
Okay. Look left.
Yeah. I've pretty much always been in security. That's not to say that I haven't done any development, but for me, it was always, you know, little kid, no friends, getting in trouble. Statute of limitations is over, so I'm not really too shy about talking about it. But now that I work for Spotify and also at my previous career at Tumblr, one of the things that I do think that I missed out a little bit on by not like spending a little bit of time in development. So I'm a security engineer. So not only am I like breaking other people's stuff, but I'm also building security tools, building security enhancements. If we find a vulnerability, I can work on fixing it myself with a developer rather than just being like, okay, you hate me now. So I think there's a lot of, there is a lot of real joy that comes from, ooh, I broke this thing. I'm like the coolest, leadest person ever, like my hoodie and my magnifying glass. But there is also this big satisfaction that comes out of like, I made this thing work. This is my baby. And then once you are working with developers, you can kind of understand sort of the psychological perspective that they're coming from when you come back to them and say, hey, there's something wrong with your baby, how that impacts them and how you need to be a little bit softer touch than just be like, I broke your stuff.
So I really have spent most of my career as a product manager, and I've worked on a variety of different products, but almost everything I've ever worked on has had some aspect of security. And I've always found that that's the thing that ends up being the most interesting to me, and also the most important piece of the puzzle to solve for our customers. And so for me, as I sort of looked at the things I'd done at a variety of different jobs, I started realizing that like I spent a disproportionate amount of my time partnering with the engineering team, the security organization, really thinking about how do we solve these things and solve these things at scale. And then I was like, why don't I just go do the security thing? Because it's the most interesting part of my job anyway. And for me as a product manager, what kind of gets me out of bed in the morning is the problems that our customers are having. And for me, if there are ways to solve the complexities of security in ways that are easy and simple for people to implement and to use and really are transparent to what's happening, that is incredibly exciting for me.
My story is a little bit complicated in that I started out wanting to be a physicist. My mom, at some point in high school, I have no recollection of this conversation, but my mom insists that she was at, I was doing my university application. She's like, Leigh, why don't you apply to computer science? You're always farting around on the computer until the wee hours of the morning. Guilty as charged. I was like, no, I want to be a particle physicist, which turns out involves a lot of computers anyway, but it also involves quantum mechanics, which I was not so good at, and somehow I eventually wandered back into computer science. But this is actually the objection that I gave to her when I was saying, no, I'm doing physics, was it turns out a very typical objection in the why girls don't go into computer science, which is I was like, Mom, I don't want to sit behind a computer all day. Mm-hmm. Which it turns out, of those of us in the room who actually sits behind a computer all day, you're talking to people, you're interacting with other humans. So much of the work in the field is actually that interpersonal stuff. And I mean, I do end up spending quite a bit of time behind a computer. But I tell all of this story to make the point that the path that I took was not the one that I expected, but it ended up being the one that I needed. Mm-hmm. So, yeah.
So I originally came into this industry as a developer, and I developed in a number of languages for quite a long period of time before coming out here to work in the security industry. And I think that background can give you a lot of strengths that you can use in security. So if you're thinking about getting into security as a developer, it's never really too late. But I also really felt coming into security after some number of years in my career that I just knew nothing, and I felt like I was starting all over again. And I found that the community, and specifically a company I worked at, ISEC, was very welcoming and helped me to kind of grow as a security engineer and has led to some really unique opportunities.
Okay. So I was always in security. I was in security before there was much of an industry to call it security. I was a software engineer working on security critical systems, whether it was financial transaction systems or actual security products. Yeah, I think it would be nice to try another space someday, but I'm really enjoying what I'm doing. So yeah, this is a fun place to be. I would say, though, if I had a chance to experience other aspects of the business, I think I would really enjoy that. I think one of the difficulties of our space is that there are a lot of folks that are very religious about their security practices. That we might hold in our heads the idea of what the perfect security solution might be, and then anything that we do that doesn't achieve that is somebody is just, they don't understand security, or they don't care about this. Mm-hmm. And when in reality, of course, they have their own criteria that they are measuring, and there's a business decision behind, assuming competence, which I try to do, that there is a business reason that they are holding the position that they have, and maybe they also have to balance things like performance or cost or a delightful customer feature that they want that undermines all of the security mechanisms that you've enabled. Fantastic. That's the real world. So I think if more of us spent more time in other aspects of the business, whether that was in sales or finance or directly interacting with users and customer support, and recognizing how expensive a security feature can be that results in customer service calls that strip away the entire margin. I worked once in a place that a single customer service call would eliminate the entire margin for that license. And so everything that we did that resulted in a customer service call was basically saying that that product is now free. So these are the considerations that I feel like as an industry we are not as open to, because we are used to doing battle, right? Like trying to convince folks that no, this is really important, and it's getting easier in 2018. But for having been in the space for 23 years, I feel like I've spent a lot of my career trying to convince folks that you actually need to do something here, and then also you should do this. That I see. That it's actually unusual for folks to actually consider what the other aspects of the business really, really need when it comes to considering these security choices, and that they're not idiots, and then it's not that they don't care about security, it's that they care about a lot of things, and they've got a lot of priorities that need to be coordinated.
Yeah, I transitioned from a software engineering to security, and there are two things that have helped me. One is assuming good intent, and second is having empathy. Because when you have these two things, you will be partnering with engineering as opposed to having that across-the-table battle. So you guys are representing, sorry, I'm so used to have been around guys. Y'all folks. Probably this is my first panel where I have all females, and I'm like, you guys, and you're like, what? So you are representing different industries here, and you have been in this space for a little while. So how have you seen the security threat landscape change over years? And you can go in any order. Like, it doesn't have to be, we have to.
Yeah, I went first last time, so.
What was that?
I went first last time.
Yeah, so she doesn't want to go next.
I mean, I think the big one that I've seen is we're just not keeping up, and I think a number of folks made points, especially Window, about the size of your application security team is never going to grow at the same pace as your code base, basically, right? And that applies both within individual organizations, but also across the entire field. So we need to be thinking about how do we move beyond just that mapping of the developer to the percentage the fractional time of a security engineer, to building tools that multiply the effects that those security engineers are having, because we're just never going to keep up otherwise.
Mm-hmm.
Yeah, I think I have something to add to that, which is when we talk to developers are not against security. It's not that they don't want to do it. They come to us and they tell us where their problems are. They tell us what they think needs to be fixed. And we need to listen to them and help them to find ways to fix their own issues and to get the business to prioritize these issues. Versus always coming down like a hammer on developers. They are caught between us and the business, and we need to be the ones to kind of be on their side.
I've seen a lot of movement, and maybe this is just because of the trajectory of my career, but I've seen a lot of movement where people are more moving towards empowering developers to have the security tools and have the security knowledge, so that we know the security team isn't acting as the mother, father, may I, where they have to come to us for every little thing, or everything has to get rubber stamped, to where we can allow them to effectively and trust them to effectively assess risk and what their threats are, so that the business doesn't just look at security as this thing that we have to pay for. It doesn't make us any money. It looks at us as an enhancement to the development process as a whole.
Yeah, I think for me, I've noticed the conversations with the engineering organization have shifted from, at the end, right before you're about to go live, whoa, have you talked to security about it? To this sort of a much more kind of proactive approach where kind of earlier in the development, earlier in the life cycle, those conversations are occurring. And increasingly, the tools that we're empowering the engineering organization with have a lot of those principles sort of already built in and baked in. And so there's kind of this proactive kind of guidance and conversation that happens at the front end rather than sort of the reactive potential kind of after the fact.
Yeah.
It's a lot less expensive that way. And I mean, just in terms of like the psychic overhead of how you work is just, it's much easier if you can have it seamlessly happen up front. And I think everybody's realizing and kind of feeling the benefit of that.
Hey,
One of the
it's
things
Thursday. We're deploying tomorrow. Can you run a pen test?
Yeah. It's like,
One of the things I find really interesting about the changing threat landscape is all the new and creative ways folks have found to monetize compromised devices and computers. It used to be once upon a time that like they would compromise a website and then they would maybe deface it because they weren't actually trying to make money off of it. And then they're hosting an exploit kit, they're using that to compromise devices, and then those devices we turn into a botnet, which would be used to send spam. And then it was like, oh well, there's actually all kinds of interesting users and passwords. I can bundle that up and sell it on the black market and get money for like a couple million username password combinations, et cetera. And then now we got things like, oh, I can mine Bitcoin over there, fantastic. Or I'm going to take that law office who probably doesn't have even an IT person, let alone a security person, and I'm going to install ransomware on their device, and I'm going to collect some money that way. I just feel like they're so creative in the ways that they've learned how to monetize compromised devices.
Yeah, my mama actually called me up last week, and she's like, Kelly, I don't know, I was trying to download a recipe, and now this thing popped up, and I called this guy, and he wants $150, and I'm like, please, just use the Chromebook, Mom.
And there's a real, like, all of this has happened before, all of this will happen again elements to it as well. I like to talk about Bitcoin as being if you were to execute a replay attack of the entire history of financial crimes on the Bitcoin network, you could predict the future of Bitcoin crimes. But the other thing that I see there is I cut my teeth on telecom. I strung cable and built PBXs for Bell Canada back in 2005. And the thing you saw in 2005, this was sort of the early days of VoIP. Asterisk was around, Cisco Call Manager, all of this stuff, and you would see toll fraud. So you have a direct path to monetize a compromised PBX because you can call premium rate numbers in various countries of the world, and the owner of that number then gets a bunch of money. And so there was a very specific direct financial incentive to be doing this kind of compromise. And we're seeing exactly the same style of attacks because there's that financial motivation happening with like crypto mining.
Mm-hmm. And I think over time, our reliance on internet, on devices has increased so much that it has made it so much easier for attackers to get a foothold. Because earlier it used to be like, we only do 2 or 3 things there, but now everything has been done there. Also, if you think about, we used to have buffer overflow issues back in, 95, 96? And we still have those. So, I mean, Kit talked all about having memory safety. Yep. So the issues that we had more than 20 years ago, they are still there. So we need to get ahead of some of these things, because otherwise our backlog is just going to grow. So thinking about this changing landscape, and I know all of you ladies are trailblazing at your organizations, the security work. What are the kind of challenges that you face? And when I talk about challenges, it could be like people challenges, process challenges, or technology challenges. Like anything, any friction you get, any support you get, like what are the things that you face day to day? And what can we do as security specialists to help overcome those?
Sure. I have one, which is, we're creating absolutely new ways to interact, but it's the same people that are interacting with it. And as was mentioned this morning, we need to challenge this idea that it's going to be really a wonderful place and that everybody's going to be really nice to each other, and now we're going to this new techno-utopia. This was the same thing that we heard in the early days of the internet in the 90s when people were just starting to get on. It's a magical information superhighway. But we see the same behaviors from the real world, just as with Bitcoin. We're seeing the same behaviors in the real world replicated and multiplied in the digital world. And getting people to build those, to think about this as early as possible in the process is going to help us to put out secure platforms and products.
I think less so in my most recent gig, but in my previous work of helping start the security teams at Slack and rebooting the security team at Heroku, getting just the sheer number of projects that we were trying to keep track of as a very, very small security team, the flipping the script from that sort of, hey, it's Thursday, we're shipping Friday, can we get a pen test, the final security review, as we called it at Microsoft, to building a practice around an initial security review, getting the product team and engaging with product to have product on board in thinking of all of the sort of checklisty items that product managers think about in building a new feature, building a new product, getting security on that very, very first checklist to say, like, what's your project kickoff look like? Is security in the room at project kickoff time when you're defining the scope of the feature? Having it pivot to that instead of that final, like, bad cop, like, you can't ship because you haven't used the right crypto library or whatever, right? Like, if you've already lost if you're at that point. So having security in the room at that first kickoff was really transformative at both of those organizations.
Yeah, so it's not a Band-Aid that you stick on at the end for any scrapes and wounds.
Yeah.
I think one of the things that I've started to realize in the past few years is that you can't really treat security as a one-size-fits-all for your organization, even if you are a very single-purpose organization. You really need to speak to all of the different areas of your company or whatnot, or wherever you're working, because the people, for example, the people who deal with content creators are going to have different concerns and different security concerns that they're worried about than the people who, take the money from subscribers. And the people who are building out databases are going to think about security in a little different way. And so again, getting away from that security is sort of like the mall cop of your company that goes around and, tells you to stop, stop sitting on the banister. You say, what is the stuff you're interested in? What is the stuff that keeps you around at night? You're afraid that some celebrity is going to get hacked, or you're afraid that somebody's going to get your financials for the next quarter release. And how can we give you data so that you can see right away, hey, this is something bad is happening, and I can now either bring in security or I can action on it myself?
I think one of the things I think a lot about is just the evolving surface area that I feel like we're working on. And part of what I wrestle with is sort of how do you get line of sight on that surface area, right? It's very hard because you can really only pay attention to things you can anticipate will happen. And it actually turns out the things that will really knock you down are the things that surprise you. And it's like, how do you just reduce that cycle time to identifying those things and then kind of quickly finding ways to build like scalable ways to kind of understand those things. The other is people never use it the way you intend them to, right? It's like, really? Like, I thought you were going to do that. You're doing that? Really? I had no idea you were going to take down that website with a killer toaster oven. Like, and so, I mean, it's good. It creates interesting problems for all of us to solve. So I guess maybe that's the silver lining, is that there are no end of interesting problems to solve. The challenge is just really kind of continually focusing on how do you get your arms around this in a way that scales, right? Because you can't keep, it's like I'm going to keep scaling the security team. It's not, it doesn't work.
Mina, do you want to add something?
So one of the biggest problems I'm facing in security is actually finding fantastic people. The entire industry seems to have woken up at the same time and recognized, oh, wow, we really need to start building up our teams, which, that's fantastic, but then it makes it really, really hard to hire fantastic people because they have all kinds of tremendous opportunities in front of them. They can work on all kinds of cool stuff, and they've got places that have like a fire hose of money to shoot at them, right? So So I guess creating an industry that finds a way to give people the skill set they need in order to be effective in the industry. One of the other talks I was thinking about doing in this this slot was how to go from being a software engineer to a application security engineer. And of course, it's the wrong audience for that because you guys are already in security. So I got to find another like a dev conference or something where you can say like, hey, come join us. It's fun over here.
One of us.
But I think creating a better way to get folks into security with the right skills that they need in order to like be effective on day one.
Cool. So we have only 7 minutes left, so this could be a little bit of a rapid fire kind of a question. If I were to ask you, what advice would you give to your younger self?
Don't drink so much.
Okay.
But also I would say be less afraid to ask questions. I think I don't think there's I think there are very few people in this room in general who have not suffered from imposter syndrome, and especially me growing up being around really, really smart people, I always kind of felt like I had to know all the answers and that I was stupid for not being able to figure things out right away. So, but I think also now that I teach, the fact that you are asking questions, pointed questions, that you are showing your curiosity and passion, it really goes a long way, not only for your personal enrichment, but it also shows people that you're someone who's not here just because, oh, I heard security makes me a lot of money, but you're somebody who really wants to learn.
I think I would build on that by saying, and follow your curiosity.
Yeah.
Like the most interesting experiences, conversations, adventures, mishaps, whatever, have happened when I've just allowed myself to ask the questions and follow my curiosity. And the biggest misses in my life have been when I sort of sat back on the sidelines and didn't engage. Yeah. And so for me, it's just that curiosity is, go with it.
And also don't just get into a field because you think it's sexy. Get into the field that you like wake up every day excited to work on.
Yeah.
I think the big one for me over the past year, I've been struggling with some burnout and just remembering that this whole career thing it's a marathon, it's not a sprint, and that it's okay to have the couple of years at one job where you like really go pedal to the metal and you stay those late nights and you bust your butt, and then have the year where like you put the brakes on a little bit and you recover a bit. And I think having that, being willing to see sort of multiple sides of the career path, because hopefully you're all going to be doing this for the next 2-3 decades, because it's not like the work's going to slow down. So setting up for the long haul, I think, is the big thing that I wish my younger self had taken more vacations.
Okay.
I mean, these folks have already said some of the things, and I would just add to that take risks, like really do things that are difficult, do things that are sometimes they're not going to be fun, right? As Anshul mentioned, I'm making a documentary. I have thought about quitting this several times, but I'm doing it because it's something that is absolutely a big risk for me. It's something I don't know how to do, and that I'm learning how to do as I go along. And it was the same getting into security, and it was the same getting into programming. So just take the risks.
So I have a couple of times told this story about how I found the hacker community as a teenager, and how I bought my very first Vax. It was a Microvax 2, and I went to the MIT flea because I knew that there were these guys selling a Microvax, and they had posted on a BBS that I was on, so I was going to go find them. And I tell the story about wandering around looking for these folks. Have you heard of the Loft? Have you heard of the Loft? Have you seen a Microvax? Is someone selling a Microvax? And I know what I was wearing on that day because I was wearing a pink T-shirt. I had my hair in pigtails. I was wearing really short cutoffs, and I was wearing these really clunky Fluvogs. It was like early '90s, like personified. So and I felt cute, and I was walking around in this environment where. So ham radio operators don't dress like this, and it was a very different space. But I remember it, and it stuck out in my mind because, so I bought the Microvacs, and I started finding more people who were interested in the stuff that I was interested in. I fell into this community, and, I had the skills to be, effective and contribute, and that was amazingly lucky for me. But almost immediately, I started wearing really baggy jeans and really baggy shirts and flannels and just covering myself from neck to ankles. And I think somehow I didn't want people to notice that I was a girl. And I say girl because I was a girl back then. I was a teenager. And then for like another, I don't know how long, I'm still wearing black head to toe, I guess. But like, there was this really long period where I didn't want people to recognize me as a girl and then a woman, and we weren't professionals. We were a bunch of, let's say, security enthusiasts who were it was a social arrangement. Even once I started working professionally and doing this, I still was somehow early on scared to be thought of as just a girl. And so I would go back and tell my younger self that it's okay to be a girl. Not right now, and it's going to suck, and all the stuff that you're going through, you're going to go through. But you'll come out on the other end, you'll be fine. You could be a girl in these years too. You don't have to I think I saw at a conference this woman speaking, and she was a CXO of some sort, and she had really long hair, and she was wearing makeup, and that was the first time I'd seen an executive with long hair, and I was just like, I was just like, oh my gosh, I can't believe I never saw one before. It never occurred to me that if you didn't have curly hair, it was definitely wrapped up really tight, and it was constrained in some way. You didn't see a lot of really obvious demonstrations of femininity. I remember there was an executive at Microsoft. I went and had a conversation in her office. And she had, sitting on the edge of her desk, not in an obvious way, this really bright, beautiful green handbag. And it was just this beautiful expression of femininity. And I was just like, oh, and it occurred to me that I guess I don't see that among executives. And I don't see, the long hair struck me as well. It's just like, we're all kind of reining ourselves in. And somehow it's not okay to be a woman in this space. And I feel like, the industry changes when we change it. So I would tell my younger self, it's okay to be a girl, and then I would tell my less young self, it's okay to be a woman. And I feel that now, and I rock it for sure. But the younger self was definitely afraid of that.
Yeah. So great set of advice from each one of you. If you were to ask me, I would say, be bold like these ladies. So thank you very much for sharing your thoughts and ideas. And thanks for making time for this.
Thank you.